Okay guys, I am such a screencast guy now. We were doing this one at the end of class and I'm just gonna fire it up on here. I figured out the right way to do it, so here we go. I don't know where this came from, but somebody brought up this structure. So if we have 6 of these in a row, okay, and one thing we can definitely establish is that it is a hex 3ene, right? Because it's got to be on carbon 1, 2, 3. It's between 3 and 4. 1, 2, 3. So it's hex 3ene. Then it had like what would appear to be an isopropyl group coming off of carbon 3, and a little methyl group coming off. Off carbon 5. I wrote a 5 instead of methyl. Okay. So my question was, when we're trying to identify the parent chain here, would we use this as the parent chain, or, so that's the red, or would we use this as the parent chain? And the obvious question is like, well, what's the difference? Well, if we use the red one as the parent chain, then we have 2 alkyl groups, right? We have these 2 alkyl groups. If we choose the green one as the parent chain, now we have 1, 2, 3 alkyl side groups. So what's the right thing to do? Make more side groups that are shorter, or make fewer side groups that are longer? And according to PubChem, which is a great online chem database, the answer is you make more side groups that are shorter. Okay, so we would choose the green one. The green one is the right one. So the actual name for this should be, so then you have to do the numbering right. Is it going to be 2-methyl, 3-ethyl, 5, or, so we can do 2, 3, 5, or we can do 2, 4, 5. What's better, 2, 3, 5 or 2, 4, 5? Well, the answer is 2, 3, 5, because 2, 3, 5 are smaller numbers than 2, 4, 5. Okay, so there's a whole bunch of overlapping rules here. But at the end of the day, the correct name for this thing in the correct alphabetical order is going to be 3-ethyl, 2, 5 dimethyl, hex 3ene, just like that one. Such a screencast guy.